So now we're going to look at factor theorem in terms of working backwards. So we're going to be given a polynomial that we know one of the factors, but we're missing one of the coefficients of one of the variables in the polynomial. So we don't know the full polynomial. All right, so we're going to work backwards. So in this first example, we're told that f of x is x cubed plus kx plus 6, and we know that x plus 1 is a factor. So aka we know, right, that f of -1, right, because this tells us -1 is equal to 0, right? So that means, right, there's no remainder if we were to use synthetic division, synthetic substitution. So we're going to set up synthetic division, and we're going to kind of work backwards to find this. So I'm going to put -1 in my divisor box, and here I want to be really careful with my synthetic division chart because there's no x squared term in this polynomial, but I still need to put that column in. Right, so I have 1x cubed, no x squareds. I don't know how many x's I have, they're using the letter k, and then we have 6 constants. So one thing that I do know here, right, is that f of x is equal to 0 when you plug in -1. So I know that the answer is 0 here. That's a number I can definitely put into my table. So I'm going to start by working forwards. So I'm going to drop my 1 down, multiply by -1, add down, multiply by -1. Okay, so then I'm kind of stuck because I don't know what k is. That's kind of the point, right? So I'm going to work backwards by saying, okay, 6 plus something has to equal 0. Well, 6 plus its opposite is equal to 0, so I'm going to fill this in with a -6. And then from there, I need to figure out what number would go here so that if I was working through my synthetic division in the correct order, I would get -6 there, right? So if we're working backwards, typically we multiply, right? So backwards is divide. So -6 divided by -1 is +6. So that must mean that this is +6. So then I have this information to work with, right? So I know in synthetic division that to get the number under the line, I have to add down the column. So that tells me that k plus 1 is equal to 6. Well, if I solve for k then, k has to equal 5. So our missing value of k is 5. So we're going to do one more problem like that. So our second example, very similar. We have x cubed plus kx plus 9. Again, no x squareds in this problem. And again, we're told that x plus 1 is a factor. So we're going to have a lot of the same setup, right? So this tells us that f of -1 is equal to 0. So -1's going in my box. I have 1x cubed, no x squareds, k x's, and 9 constants at the end. And then I know that that is a 0, and that should go here. So again, I'm going to work forwards to start until I get stuck with the k. So drop the 1 and multiply, add down, multiply again and get +1, and now I'm stuck. I don't know what to do. Right, so now we're going to work backwards, right? So what number has to go here in order to add and get, we'll do this color, right? In order to add to 9 and get a 0 as my remainder. Well, that must be a -9 since 9 plus -9 is 0. And now I want to work backwards over here. Right, so typically I would take whatever number's in that purple spot and multiply it by -1 to get -9. So if I work backwards, right, by dividing, I get +9. And then I know, right, if I add down this column, k plus 1 is supposed to equal 9, which means that k has